Hello, my name is AP, and today we are going to be continuing our Lightweight Java Game Library series. Now, in the previous tutorial, we added third-person cameras, and so that's actually going to be the end of that, and we're going to be moving on to something else, something actually a bit more important. We're going to be moving on to 3D model loading, and so right now we have a pretty good system where we can load 3D models and it can understand what we're trying to say, but it's a bit long-winded. It took us like 60 lines of code just to define a cube, and that's just too much. So now what we're going to be doing is we're going to be using Lightweight Java Game Library, like a library in the Lightweight Java Game Library called ASIMP, and that actually stands for Asset OpenGL Loading, or at least object loading or something like that. So instead of having this boring old cube, we're going to actually have some 3D models that we can get from any source. And it's not going to actually be OBJ specific. It can actually be any model due to actually using a library in Lightweight Java Game Library. So the first thing we need to do is we need to modify our Vertex class, because when we load something, a 3D model, we are going to need another set of vectors. So graphics, vertex. So it's pretty simple right now, but what we can do is we can add another one. I'll add it right here because it's a vector 3 called a normal. And now what a normal is, it's basically telling how a face is pointed, so like it's perpendicular to the face and how it's pointed. These are very useful for lights and shading. So, and this is also useful for cooling to see if the face is actually in the camera's view. So now we need to add another argument in here. It says normal, and say this dot normal is equal to normal. Yeah, okay, cool. And then we need a getter for it, so public vector 3f get normal, return normal. And so when we do that, you can see that there's going to be a bunch of errors. We actually do not need this anymore. We can actually get rid of how we do this, and so we're just going to say mesh is equal to null so it can stop doing errors. As you can see, that took out a lot of classes, and so this is going to simplify things just a little bit. So now that we have modified our vertex class, we need to actually create the class that loads the models. So I'm going to go into our IO tab, which is input and output, and create a new class, and I'm going to call this model loader. And in here it's only going to have one method for right now. It's going to have a static method called load model, and oh yeah, it needs to return a mesh and import mesh. And so what we need to do is we need to actually get a few things to actually find the model. So first we need to have the file path to the model. Ooh. I don't want to print. I want to do my file path. And then we also need a path to the texture. So texture path. And so in here we can actually initialize ASIMP by creating a scene. So AI scene, and then we're just going to call this a scene. And we're going to load the model by using AI import file. And for right now, it is not going to be using a class path. I will fix this later on. But just to make things simple, we're just going to be using the standard method. And so this is where the file is located. So we're going to do file path. And then we have p flags, which are the arguments on how you want to load this. And so just to make things simple, we're only going to have two of these, and they're the same as the OpenGL flags. like as in you have to bitwise OR them to like have multiple. And so since we have AI process, we need the join identical vertices, and the bitwise OR, and then we need async dot AI process, and then we need triangulate, because on our engine can only support triangles right now, and that will actually crash if we give it more than just a triangle. Alright, so now that we have our scene, this contains all of our 3D model data. So we need to actually check if it loaded. So if it didn't load, that means scene is actually null. So if scene is null, then we can print out an error saying print line couldn't load model at, and then wherever the file path is. So this is just to see if there is no file there, and that makes it so much easier. So the next thing we need to do is we actually need to get the mesh of the 3D model. So we can actually create a async mesh, and then we're going to just call it mesh, and we're going to create a mesh, aka just create a mesh object, and we need to do it through the scene, because the scene holds all the pointers to the data. So we need to say scene dot not get m meshes, and then we need to get the first one. If for some 3D file there's actually more than one mesh. I'll get to that in the next tutorial where we actually finish loading this up, but for right now we're just going to do some basic loading. And so we're just going to get the first mesh, aka there's only one mesh. So after we do that, we need the vertex count. So int vertex count, and that's just going to be the mesh and then the number of vertices. For some reason, all methods in async start with m and then whatever you need, so number of vertices. And so now that we have the number of vertices, we can do a for loop to actually add the vertices into our mesh object. So we need to actually create a buffer of vertices, so like the vertices from the mesh. So we need to create a buffer of the special vectors, so AI vector 3 dot buffer, and this is where the vertices are, and then we need to store the actual vertices. Similarly to how we have the meshes up here, we have to do m vertices, and we need to do the same for normals. So instead of calling it that, we call it a normal, and instead of m vertices, we call it m normals. So that works for two of them, but then when we actually get to textures, we need to do a different thing. So let's actually create the for loop. So for int I equals 0, I is less than vertex count, and then I plus plus. And so this is just going to go through all the vertices and add them into our object. And we actually need to create that object. So if we go into where our mesh is created, you see we need a list of vertices, a list of indices in the material. So we actually need to create a vertex array to hold these. So vertex list, and then that's just going to say new vertex array with how many vertex there is, how many vertices is in the mesh. So now that we have that, we need to do in our for loop and actually add the vertices. So we need to get the actual vector. So as you can see, we're looping through all the vertices and normals. And then we got buffer vertices, or vertex, and that's going to be equal to vertices.get, and then whatever oh no, this is, there we go, wrong one, there we go. So now that we have our vector, we can actually get the information out of it. So we can actually convert this into our own vector class. So let's say mesh vertex, and we need to actually create a new vector3f and then set them into here. So vertex.x, vertex.y, and vertex.z. And so import vector3f. As you can see, we have converted one of these vertices in this buffer into something that we can actually make ourselves. So now we have that. We need to do the same for normals. So I'm just going to copy this because it is quite similar. But instead of saying vertex, we say normal, normals here, and then mesh normal. Replace all the vertex with normal. So now that we have that, we need to actually get our texture coordinates. And like I said, it's a bit different. So I'm actually going to set the texture coordinates. So mesh texture chord, and that's just going to be initialized to 0, 0. Let's do that, and then our vector2f. And so we need to actually check if there is a texture coordinate, because sometimes models don't have texture coordinates, and if they don't, then we're just going to default to there's no texture coordinates, set them all to 0, 0. So that means that if there's actually a texture coordinate, so we can actually check that by checking the number of UV components, which is just texture, and we can check if the first one, or actually let's do it like, can I do length dot length? I don't know if, is there a way to do that, or do I have to do, well, I can't do that, so let's just do that. If the first part of the texture, if there's no texture coordinates, then don't do anything. If it's not, okay, hold on, I'm sounding stupid. Now that I've written it, I can actually explain it. Okay, so we have our texture coordinate, we have defaulted it to 0, 0, and if there is actually something, if there's something for the UV components, aka there is texture coordinates, then we're going to set it to those texture coordinates. If not, then it's already defaulted to 0, 0. So the next thing we need to do is we need to do AI 3D texture, and then we need to do, actually get the texture, so mesh dot m texture coordinates, and then the first one, of course, because, you know, this, actually, no, we don't have to do it like that. We have to do I, or no, oh, 0 dot get I. I have notes, by the way, in case you didn't know. There's the notes right there. It's Visual Studio Code. And I'm just trying to look at it so I don't sound stupid. But it's not working because I'm still sounding stupid. Anyways, what this does is it gets the first texture, because obviously the first one's going to be the first UV component. It's usually going to be the texture. And then it gets the texture coordinate for the vertex. And then finally, set the mesh texture coordinate to whatever that is. So chord dot set x to texture dot x, and then set the y to the texture dot y. And we don't need the z value because pictures are 2D and not 3D. So now that we have all of this, we can actually create our vertex and add it to our list. So vertex list of I is equal to new vertex, and then we need our vertex actual position. Mesh vertex. Then we need the normals because we just added that in this tutorial. And finally, we need the mesh texture coordinates. Mesh texture chord. And so now we have all the vertices converted into R's, and so we actually need to create the indices. So after this for loop, we need to create another for loop, and we need a face count. So in face count, and that's going to be how many faces there are. So m num faces. And then instead of calling it vectors 3D, we need to say AI face, and then of course buffer because there's a list of them. And we're just going to call this indices because that's what they're actually called. And then we need to get those actual faces. And then finally we need the indices list, and so that is an int array instead of a vertex array. So indices list. And that's just going to be set to new int, and then the face count. But since there's 3 points on a triangle, we need to actually multiply this by 3. Because if we go to our mesh, or actually I kind of deleted it. Anyways, basically you need 3 points to describe a triangle, and so each face needs 3 points. And so now we need to have another for loop. Int I equals 0, I is less than face count, and then I plus plus, and so that loops through all the faces. And then similarly to how we do the vertex up here, when you do AI face, and then just do face is equal to indices dot get, and then whatever the I is. And then set that to, and they set the indices in the array. So our current face times 3, because remember we have to do face count times 3, and then offset by nothing because this is just the first one. And then this needs to do face dot, and then we need to get the indices of that face, because remember the face is not the indices, the face is the triangle, and then once we get the indices for the triangle, we can actually get it. So we need to get the first one, which is 0. Indices list, not indices. And so we can just copy and paste this multiple times. 1, 2, and 1, 2 for the other 2 points. And that is actually all we need to do. So we have all the information we need to create a mesh. So after all this, we needed to say return new mesh, and then we need the vertex array, so vertex list, the indices list, and for right now we could just create a material based on the texture path. So new material texture path, and so import material, and as you can see, no errors exist, everything's imported correctly, and this should work. So now, to actually fix this, we need to say public mesh is equal to model loader dot load model file path. Well, we don't have a file path. In texture path, we're just going to use beautiful again. So textures dot beautiful. That's not how you spell beautiful. Beautiful dot png. And file path, well, let me go get a dragon real quick. So I'll just go off screen right here. So tutorial, that one, resources, models, and let's grab our usual dragon. So if you've seen the last tutorial, you know that it's that you know that we usually used the dragon for our 3D model, and so we're going to be using the same thing. So in here we're going to create a new package called models, and I'm just going to paste the dragon in there. You can get the dragon object in the GitHub, or you can get your own 3D model. It should work for any of them. And so finally we need to do resources, because remember, we're not doing any class path loading, /models /dragon, and then for this one it is an OBJ file. So now if we do all this correctly, we should see an error. That's not good. Null point exception. Hold on. Okay, sorry, it's just stupid. I forgot the front thing right there. Probably should have an error for that. So now if this loads correctly, as you can see, it is an, oh, that's why. Should have changed that. Yeah, we're kind of rendering 500 objects. Let's not do that. Let's not render 500 objects. So let's just anytime it's okay. So let's not do that, because there's a lot of triangles on this. So now if I zoom out, as you can see, we have ourselves a beautiful dragon. Zoom out a bit more. With beautiful the beautiful.png in it. There is no mip mapping, which means that like a farther away, it's less detailed, and further in it is more detailed, but so it looks very staticky, but who cares? I'm actually going to switch to first person camera so we can do a better close-up of the model. And as you can see, it works pretty well. Not really complicated. I mean, I explained it terribly, but it should not be complicated to understand. And yeah, and it also works for multiple file types, not just OBJ. So I'm actually going to bring in another file called bunny.stl. And if you've been around 3D modeling, you should know what this is. I'm actually going to make it smaller because it's a really big model. Tutorial models. Here we go. So drag that in here. Copy files. As you can see, bunny.stl. And so just change this to bunny.stl. And of course, like I said, I will make it smaller. There we go. And it should load up. Oh, I'm in the bunny. There we go. So yeah, there's the bunny right here. Usually this doesn't have a texture, so like there's no texture, so it's just 0, 0. It's just a very white thing. And also it's kind of rotated, but who cares? As you can see, it's sort of bunny shaped, as you can definitely see from this angle. And so this is the Stanford, or no, this is the, what is this? Who made this? Is this MIT? I don't know which one did it. Anyways, so this can load multiple types. Anyways, that is going to be it for this tutorial. In the next tutorial, we should be finishing up, and we should be adding like making async complete by adding multiple texture loading, multiple mesh loading, so you can have like an entire scene there, and just to make it a bit better. And then hopefully we should be done with model loading after that. So anyways, and that is it, and I will see you guys in the next tutorial. Bye.